Well, morning all. Here's a Baumuller type BUM60-30//A-010-B. And the problem with this drive is every now and then, intermittently, it will fail on the IZK alarm. And IZK is an LED right here, H7. IZK. Now what IZK stands for is overcurrent in intermediate circuit. So I've got this variac right here, and I'm going to apply 200 volts or 220 if we're coming off the wall to this Phoenix connector right here. And that connector is X5. Now be careful. Some of these drives, there are 24 volts DC coming into this connector right here, so make sure of your version of drive. This one right here, you need 220 volts AC on these two pins right here on this X5 connector. So be careful. Once we power it up, we're going to look at the voltages and see how the voltages look. A lot of times when you have an intermittent problem, go to the power supply and look, see how that is. If the power supply looks good, you have to go in a different direction. But if our power supply is bad, we're going to fully take this drive apart and recap this power board right here. So I'm picking up ground on this connector right here, ground of the logic, and we're going to look at voltages with the Fluke oscilloscope. Now, I like these drives because you can either apply 220 volts single phase to this drive connector, this X5 connector, and power up just the control, or you can come in this connector and power up the control and the DC bus for the motor. But here, because I'm coming in to this connector only, the high voltage section is not going to get powered up to run that motor. So if for instance I misprobe something or put two pins together, it's not going to be as critical as if I had that motor side powered up too. Does that make sense? I always try to be a little bit careful there. So here we go. Let's power things up. I've got the fan disconnected so we wouldn't have any fan noise. Got that heat sink cooling fan disconnected. I'm going to go over here on the, let me get my close-up glasses on here. I want to go look. Here's our 3 current sense modules for U, V, and W. And there's some LM311 comparators down here. I see 1, 2, 3, and 4. I am going to see if I can look at the power supply. I see some spikes there. Let's look at this side and see what it looks like. Oh, yeah, there's something going on there. We'll get close to the oscilloscope and we'll look at that. Let's go look at the logic. Yeah, we're going to have to recap this board or find out why our power supply looks horrendous Let's get close to that oscilloscope right there, and you can see what I'm talking about. Okay, we're going to look at the 5 volts for the logic. You see that right there? You see that ringing? That overshoot and undershoot? That should be a good solid 5 volts right there. Now this right here would cause those current sense to intermittently fail. And for that matter, the logic would be having a hard time doing its job. Oh, slipped off. There we go. Okay. First thing we'll do is a recap on that power board. And then we'll see what it looks like after that. Come on. Don't be stubborn. Oh, I gotta undo these wires right here to undo the regenerative braking resistor from the power board. There we go. Oh, look at that. It's interesting. Somebody's been in here before. Looks like we had a previous explosion and somebody repaired the board with this red jumper wire. Interesting. You can see where it blew into the insulator. Yeah, that's an old explosion. I can't smell it anymore. Usually a fresh explosion, you can smell the semiconductor that burn up. Well, this poor drive's seen better days. Okay. Let's get this off the board here. There's probably going to be some capacitors in the firing channels that we have to get to. Usually these are Phillips screws. These are star. There's our cooling fan. Spins good by hand. Here's the regenerative braking resistor right there. And how many ohms is that? Looks like 15 ohms. Let's get our meter and we'll measure that. While we got it out here, might as well check it. Yep, 15.9 ohms. That's a good resistor. Set this down here on the floor. Yep, there's some resistors under here that I would like to change also. I'll get my camera and I'll take a picture of those red wires, make sure I get them put back where they belong. Going to remove the IGBT from the heat sink assembly so we can get those capacitors up underneath the heat sink. There we go. Now for the fun part, we get to recap that board. Some of the caps I'm not going to recap. I'm going to recap all of the feed-through capacitors and only a couple of capacitors in the switch mode power supply circuit that are surface mount. I do not like taking surface mount capacitors off the board. I can do it, but I just don't like to because there's the chance of ripping up a trace trying to take that capacitor off the board, that surface mount capacitor. So, well, y'all can go get you a cup of coffee while I'm doing this recap if you want to. Let me put my tools back over here in this toolbox. Or you can sit here and watch me do the tedious work. I don't know how many boards I've recapped, and it's always a challenge. Well, here we go. Before I start removing capacitors from the board that I'm working on, I'll make a diagram, a layout of where the capacitors are on the board, their ferrite values, their voltage values, and their polarity. So for instance, I'll draw these two capacitors, 22 microfarad at 400 volts, and I'll put their little ground marking on the position of the board. And I do that for each capacitor on that board. Even the ones I'm not going to remove, I still put them on the board on my drawing so that I'll have a relationship of where these other caps that I've removed, I'll have a position relationship of where the other caps go. The easiest way to remove through-hole electrolytic capacitors is to heat up one side and rock that capacitor back this way. Heat up the other side, the other lead, and push that capacitor back that way. And keep rocking it back and forth until the cap falls off the board. I'll show you what I mean. Now I'll take a little bit of solder and add it to the old solder to help the new solder flow. I'm heating up this one side, rock the cap this way, heat up this side, push the cap back the other way, and keep rocking that capacitor back and forth until it comes off the board. Now we'll take our solder sucker and remove the solder from the vias. There you go, just like that. Isn't that easy? Now let's go find the other ones. That was this capacitor right here that we took off. Just like that. And that is a 220 microfarad 25 volt capacitor. I'm going to take these off. We'll take these off. And I'll debate on whether to take those surface mount capacitors off. I'll battle with myself. Do I want? No, I don't want to. Yes, you have to. No, I don't. Let's add new solder. Oh, oh, dropped that one on the floor. Let's go get it. There it is. Okay. And up the other side. Just keep rocking back and forth, applying heat to either side. There's that one. There's that one. Rock that capacitor in the opposite direction of the lead that you're heating up. Don't try to force it. They'll get there. There's that one. Let's see what we've got now. Okay, that's the row of caps that we just removed. Let's get these two right here. There's that one. Okay. There's that one. Let's see what we got now. Okay, we removed this one, this row, and these two right here. Let's get this one right here. Heat up one side and rock that cap off the board. See what value this one is. That's 100 microfarad at 25 volts. Okay, now we'll go ahead and remove the solder from the vias. Now we'll take these two off the board. heat up one side and rock that cap off the board. There's that one. Let's get the next one. There's that one. There they are. Look at that. 220 microfarad at 25 volts. Backside of this power board has seen better days, I'll tell you that. It's in bad shape. Must be a real bad environment this drive lives in. Let's go over to the firing channels. We'll take these three caps off the board. I'm going to go ahead. Firing channel voltages are very critical. I'm going to go ahead and replace these two surface mount capacitors. I'll show you how I do that, but let's get these electrolytics off the board first. There's that one. The second one. There's the third one. Let's see what their values are. They are 47 microfarad at 25 volts. I'm going to leave these two here on the board, these 400 volt capacitors, because it looks like somebody has already replaced those. I'll go ahead and hot glue these together so that they're not sitting there wobbling around. Let's go ahead and get these guys off the board here. You have to be very careful with these surface mount capacitors because you don't want to rip up the traces. You'll have to do some trace repair if you do that. And we don't want to do that, so we'll get those two off the board. And I'm debating on whether to replace these two in the switch mode power supply section. Right here's the switch mode power supply I see. I think if I can get down on those, I'll replace those two, but these are fairly out in the open without too much in the way. So we'll get those first. Alright, let's see if we can get these two capacitors off the board. I don't know if y'all can see it, but there's leads on the top side of the board, and what I do is I add a little bit of solder to those leads. This one's got a diode beside it. Hope I don't knock that off the board. Now, you'll heat up one side and rock it back that way. I'm going to get in the way, but you'll get the idea. And just be very gentle. Be very gentle. And eventually, are we still in the picture? I push this that way a little bit. I've come out of frame there. There we go. So we'll heat up this side, push it that way. Looks like that side's come undone. Heat up the other side, and there we go. It's off the board. Right there it is. Now let's do the other one the same way. Just bring that one back in the frame. So easy to get out of the picture when we're this close to the capacitor with the movie camera. Heat up both sides. Push it that way. Heat up the other side. Pull it back this way. Heat up that side. Don't force it, because when you force things is when you get into trouble. There we go. We're off the board. There we go. There's that one. And it is 100 microfarad, 50 volts. I'm going to replace those. Sometimes, and it's really aggravating when they do this, but they'll put a drop of glue to hold it to the board while it's being soldered. But luckily, these ones they came off very easy. Nice. There they are. And if I can do it, you can do it. All right. Alright, we're going to take a standard capacitor, bend the leads out. This is 100 microfarad at 50 volts. Bend the leads out so it looks like that. Then we're going to trim the leads back with our wire cutters. So that it looks like that. Now, let's add some solder to one pad. Let's go to this one right here. Now, we might have to trim those leads back if we didn't trim them back far enough. Let's do this one in the back first. Don't install it backwards, people. Yep, let's take it back just a little bit more. Make them a little bit shorter. Now, I don't know if you can see that, but we're going to hold that lead over the pad and melt the solder. Get on her. There we go. I think we got it that time. Yes, we did. Now we're going to heat up the other side, the other lead. Let's add a little bit more solder to the first side. There we go. Let's do the second one. Bend the leads. Cut the lead, that lead. So it looks like that. Let's install that one. I wish I could get my hands out of the way, but I just have to make do. Got that side set. Add solder to the other side. Add solder to the first side. There we go. That's easy, isn't it? Alright, let's install some new capacitors. We'll start over here. These are 47 microfarad at 25 volts. Don't fall out. Don't fall out. Let's see. Okay, who's next? Let's go with this one. This is 100 microfarad at 25 volts, and it goes right here. Let's put these two in. Those are 220 microfarad at 25 volts. Now this right here is a 35 volt version. I'm running out of smaller 25 volt ones, and I want to put those over here. So let's put the 35 volt right here. It appears we have a little bit more room over here for those. Now we'll install this one. 2, 3, 4. That's 25 volt. 25 volt. 25 volt. 25 volt. And that's 25. I'm going to use the 25 over here. See what we got. See, there's the 35 volt right here. We're going to put that one down there. I want to use the smaller 220 microfarad capacitors over here. See, there's 35. Microfarad at 25 volts. Let's get those two started. You can see why I wanted to save the smaller 220 microfarad capacitors around this corner right here, because there's no room. They sit side by side. Larger capacitor over here wouldn't fit. They'd bump into each other. Let's get these guys started. There we go. Now, let's think about these two capacitors for a moment. They're in the switch mode power supply circuit right here. And this part number, let me see what that part number is. We have, get my glass here, the UC3844B, manufactured by ST. So let's go ahead and try to replace these two capacitors right here. It's going to be a bear. There's not a whole lot of room down in there. But we'll try. We'll give it a go. All right, here we are. We're committed. Let's get the hardest, easiest one first. That'll be this 100 microfarad 50 volt. I gotta get my close-up glasses on so I can see what I'm doing. Okay, here we go. We're gonna apply solder. The problem with this one is we have an IC right here and a capacitor right there. And I'm going to try to get in here without melting anything. Add some solder to that lead. I'll take my hat off so it don't get in the way of the camera because I'm going to have to lean over this way. Oh, there's no room in there. Here we go. Okay. Let's add a little bit of solder to this one. Okay, raise up that side a little bit. Now heat this side up, push it that way. Okay, almost there. One more time maybe. There we go. We have that one off the board. Let's try for the 10 microfarad at 50 volts. Add a little bit of solder to the lead. Don't burn your finger, Peepaw. Try not to. Well, I got to get something down in there. Let's try a screwdriver. That one's so small that I'm burning my finger and my thumb trying to move that capacitor off the board. Okay, there's that one side lifted up a little bit. Okay, that one's free. Okay, we have both capacitors removed. Let's take our solder wick and remove the solder. After we have these two capacitors replaced, we shall power up the control and see what our voltages look like now. I'm trying to think and work at the and talk at the same time. I keep getting in the way of what I'm trying to say. Okay. Here's our 10 microfarad. It's going to be fun doing this, but we'll do it. Okay. See, it goes in that way. Okay. Now let's apply. Solder to one side. This will be our anchor point. We'll get one side anchored down. And then we'll solder the other side. There we go. Add a little bit more solder to that back side there. That's better. That's better. Okay. Now for the 100 microfarad. There we go. There's all the caps I wish to replace. These two were the toughest. They were a bear, a grizzly bear. Just no room to get down in there without melting anything. And I got the corner of that capacitor right there. Got my iron on that. You can see the little bit of melted plastic on that device right there. Oh well, it'd be okay. Now, in just a little bit, we'll power up the control and we'll see what our voltages look like. Let's see what our 5 volts looks like now. Oh, much better. Much, much better. I like that. Looks like new capacitors solved our problem. Let's get closer to that scope and y'all can see what the 5 volts looks like now. Let's take a look at our 5 volts now. Doesn't that look good? That looks good. That was a tough one, especially those surface mount capacitors. I don't like changing those unless I have to. Good job, all. You fixed another one. Have a good day where you're at, and we'll see you next time.